Welcome everyone to InRhythm Lightning Talk. For those who don't know me, I'm Parag Katkar. I'm the head of consulting practices at InRhythm. And as a part of InRhythm's quarterly summit, we are hosting a series of hands-on interactive coding workshops on the latest technology trends. And today we are hosting the third workshop of this series, which is our iOS workshop. A little bit about what the quarterly summit is. So learning and growth is a core value for us at InRhythm. And the thought leaders at InRhythm, they identify the latest trends in the industry for each of our practice areas. Then they plan weekly lightning talks on those trends. And end of every quarter, we host a quarterly summit where we go over the summary of all the technology trends for that quarter. And then we do really in-depth hands-on coding workshops to learn those skills, because we have found that that's really effective to really go hands-on, where our practitioners also discuss their learnings and then they share their knowledge on how they're applying these skills on their project work as well. So that's the way we learn new technologies. And I'm really excited for today's workshop. So without further ado, I'm going to hand it over to Nader to go over the agenda for today's workshop.
Awesome. Can you hear me?
Yep.
Okay, great. So thank you all for joining me. Like Parag said, we're very excited about this. Async await is, I think, it's definitely going to make a lot of changes, simplify things, and I'll go over an overview about what to expect from the workshop, as well as an overview of async await before I hand it over to the amazing team that has been working on this. So Parag introduced himself. My name is Nader Khraizat. I'm the mobile engineering manager and focusing on the iOS practice within InRhythm. And we're bringing in this talk for async await. And then just giving a quick introduction about some of the presenters that we have. We have Joshua Buchanan and Hamid, who will be doing a big portion of the presentation themselves. We have our awesome team as well of engineers in case there's any help that's needed or anything. So instead of disrupting the workshop, what we're going to do is we created 4 breakout rooms, and then you can send a message in chat. Chat is being monitored, and you can join one of the breakout rooms, and we'll have one of the engineers who's able to join. Now, this is only if you're having some technical difficulties or anything. If you have anything specific to async await or anything related to the workshop, we do encourage you to ask those questions. So with that said, we'll just do a quick overview of the agenda today. So we had our kickoff with Parag, and I'm going to do the introduction and just doing a walkthrough. And then Hamid's going to take over. He's going to do an async await overview, talk a little bit about the pros and cons, and then why is it needed, the value it provides, and some of the error handlings. And then this is where it's kind of gets exciting, right? Because what we want to do is want to have this as an interactive coding session. We don't want it to be, just being on a blank screen or whatnot. We would definitely encourage someone to share their screen and go over the code and speak out loud, tell us what they're planning, how they're doing it. And it's okay if you don't know it. That's the whole purpose of this workshop, is that we want it to be interactive. We want people to participate. And as we know, that there isn't just one way of doing things. So the more input we have, the better it is. And the more productive this workshop would be. So we'll do like a quick overview of the setup. We made a lot of changes to make it super easy, and all you need to do is just download the project. I believe there's an email that was sent out to everybody. I posted it in Slack, and Kayla will post it in the chat here as well. Just the repos, and then just some of the instructions that you would need. Then after that, after long discussions and brain power, we all need a break, so we'll take a 10-minute break, and then we will go through, the differences between combine, closure, async await. And I think that this is really important because, what we're trying to do is, it's not just understanding how async await works, but also if we have other instances where, we have already existing code and whatnot, and we need to change that code into something else. We want to see the differences between each one of those, and then how to do that conversion. So once Josh is done with that coding section, he's going to do a live demo and just do a walkthrough. And then finally, we're going to have a structured concurrency session as well. So we're going to talk about task group, detached, and async lab. And then we'll go through each one and just kind of show the differences and where the value is in each. And at that time, definitely need another break. So we'll have a 10-minute break, and then we'll jump into the interactive coding session. And again, I really encourage you to, volunteer and just come in and say, I want to do this, and be able to, kind of share your knowledge and hear what others have to say as well. And then finally, after the whole session is completed, we want to have a discussion. We have a set questions that we have. So we can ask those questions, as well as any feedback, any comments that anyone wants to talk about. What you liked, what you didn't like, would you use it, would you not use it? And then finally, what we'll do is we'll do a wrap up. Parag would just end the workshop, and then I'm personally gonna stay over, see if anyone wants to talk, just socialize and see if there's any other questions that that the team has. And this is just a quick, just kind of like the instructions about where the project is and how to download it. Pretty much all you need is the link and Xcode, and you would be able to open the project. So with that said, there's a lot of common questions that get asked. What is async programming? What is async await? And why would we want to use it? And there's some conception that it's only used for network call. And what I'll do is I'll give a quick overview about it here, right? So first, let me start by defining what is async programming. Well, async programming is the ability to execute tasks without blocking the main thread. That allows the app to be responsive for user interactions, and especially if you're doing things that consume a lot of time on network requests, or trying to input or output a file. Now, traditionally, handling async await in Swift has been using callback, closures, completion handlers. However, that does lead to a little bit of a complex code that's hard to read and maintain, and multiple nested closures that would be hard to follow. And that is where the magic of async await comes in, right? So async await is it is a programming pattern that allows developers to write async code in a synchronous way, using the async, await, and try words. So by using async await, you can avoid nested closures, callbacks, and make the code easier to read and understand. In addition to making the code easy to understand, async await also has performance benefits. And by using async await, you write more efficient code that can improve the performance of your application and have a better user experience. And finally, async await is not only used for networking call, although that is kind of like a big portion of it. But if you're parsing large data, or performing extensive calculation, or any database operations, and a few other things, like if you're trying to convert an image or any of that, that does take a lot of time, and you can definitely leverage async await with that. And And with that said, I will open it up to Hamid to talk a little bit about, to do a deeper dive into async await. So Hamid.
Yep. Thanks, Nader. Hello, everyone. Thanks for joining. I'm going to share my screen right away. All right, so the first talk of this workshop is async await. I'm hoping everyone can see my screen clearly here. All right. Let me get started. Yes. Okay, so what is async await? We are hearing this not a long while back. Async await is a mechanism or a tool to perform asynchronous tasks in iOS using Swift. So when I said asynchronous tasks, you can perform network calls that are asynchronous. You can perform asynchronous tasks at app level. Those can be multi-threaded tasks. Those can be user interactive tasks, UI related, or any kind of app-based app level tasks that you can perform in async fashion. You can utilize async await mechanism, latest in iOS 15 with full feature support. What should be the syntax of async await? How does it look? Is it really complex, like older techniques, writing verbose code with combine or completion handlers? No, not at all. All you need is to use async keyword with the function that you're writing. So your function is actually the task that you're going to perform. Whatever inside the function is going to be a task, and that task is going to be performed in async fashion. Now, wherever you want to call your async function, you just need to mark that method with await keyword. If your task or function is throwing any error, you can mark await with try. Otherwise, await is just going to be sufficient to fulfill your need. You can also use, in case of errors, you can use do block that's going to execute your actual task, and catch block in case your task runs into any kind of error. Pretty simple. You don't have to write a lot of code in short for using async await mechanism to make any kind of asynchronous calls. Now I'm moving to the support and availability of async await. So async await is fully functional. It's Swift in iOS 15, minimum with Swift 5.5. It's also available in iOS 13, but with the limited support. You can use Xcode 13.2 for that backward compatibility, that you can use async await in iOS 13, again with limited support, since the Swift features are not fully available in iOS 13 in 5.5. So, but you can still use it in macOS, for macOS, Catalina development, watchOS development, or TV iOS 13 development. iOS 15 is the perfect and the right starting point if you want to fully leverage async await features completely. What can be the benefits? Why are we choosing async await? Why not combine? Why not completion handlers? So there are many reasons async await, the modern technique, has become popular now. I'm going to go through the benefits one by one, and we'll explain them as well. So the main benefit, the main selling point of async await is the structured concurrency. So what is structured concurrency? When multiple long-running tasks are running in asynchronous fashions, they are self-managed in terms of managing resources, error propagation, or can handle any kind of concurrency issue on their own. Because of async await, we have the pattern we have available from Apple. That makes its performance really good. Lightweight tasks, resources are managed properly, clean code. You don't have a lot of lines of verbose code like you write in completion handlers and goes back and forth for the calls. There is an error handling in async await, which is very precise. As I showed, like all you need to use is try, do, and catch. Only 3 keywords, and that's gonna be enough for your error handling in async await. So in short, it's precise. Structured concurrency is amazing. Overall concurrency is very well structured, I would say. Code is clean, and you don't need completion handlers or block of codes to call back and forth. Let me show a code example of how you can handle error in async await. So there is a function, it's a sample function, fetch summary. This function is fetching summary of a stock using symbol. And all you need is to use throws keyword, because your asynchronous function can fail. There may be a chance due to any error. Put throws keyword, perform your actual execution in the do block. And if the do block runs into any kind of error during the asynchronous function, during the running asynchronous function, you can catch that error in the catch block. And that's all you need. Nothing more, nothing less. Now, when you write an asynchronous function, you can, with the SwiftUI MVVM pattern, you can create a view model layer. And the view model layer, all you need to do is call your asynchronous function by marking it as a main actor. When you mark your function main actor, SwiftUI is going to take care of your call by itself. If it's a user interactive session, SwiftUI will automatically handle using async await all of your task execution into the threads wherever the right place is in the SwiftUI. Moving next to, as I explained, structured concurrency, we will be going in depth. It's a separate talk, and you will also know what it is in detail. So I want to explain here the power of async await. So basically, when an asynchronous
Hamid,
function is running.
Hamid, question, this is Raj.
Sure.
The main actor, is that mainly to take care of background thread versus main thread?
Yes, main actor actually take care of the main thread. Yep.
Okay.
Yep. So async await is powerful in a sense when you're performing an asynchronous function. So what does await do? The await keyword performs or runs your asynchronous functions task and put your actual function on suspension. So once your function is suspended, your task completely focus on your awaited function, awaited tasks. As soon as your awaited task completes and returns, your function actually resumes, and then it returns. So with async await, you have the power of await is that it will complete the awaited task first and then resume the function, and then function is going to return. So in that case, during this whole process, you may see an error and catch it in your catch block. If you don't see any error, your do block will get the job done and will return the required results. As I mentioned, structured concurrency reduces a lot of concurrency issues like deadlocks, race conditions, mismanagement of your resources, including your space complexity, and all different sort of concurrency issues can be handled better with this structured concurrency pattern that async await has implemented under the hood. As I mentioned, we will go in depth in the next talk soon within the same workshop. Now I will be moving to the next piece, which is the counterparts. As I mentioned, async await is a modern technique that it's pretty new, but it also has counterparts as well. And these counterparts are still in use. People are using it. It can be combined. It can be completion handlers. So combine came before async await. Combine works on dispatch queues mainly. You need to handle dispatch queues explicitly in combine. With completion handlers, you have to write block of codes, do the callbacks, write closures, and do some more manual management. But with async await, you just need to use async await keyword and mark your method as a main actor in the view model, and you should be all set. So definitely async await is more concise, precise, well structured, and structured concurrency is definitely its main selling piece here for async await. Yeah, and pretty much it. We will going into the depth sooner further related to the async await in next talks. Any questions? There are resources available online. If you want to look at these resources, I would highly recommend the first one from Apple, because Apple has a great description about async await. And that's really going to help for the people who want to know the details or want to practice it somewhere later on. Yep, that's all from my side. Feel free to ask any questions.
Well, I have a question.
Yep.
I haven't been using async await because I'm used to NS operation and the dispatch queue. But how are we manage quality of service, and how do we create custom concurrency threads if we want?
Okay, so you don't need to manage the queues yourself like you do in the case of dispatch queues. All you need is to use async await keywords like I showed here in the code example. And wherever you're calling your asynchronous function, which is most likely a view model, just mark as the main actor. So the main actor, when you mark a function main actor, it just takes care of the queue itself under the hood. So you don't have to explicitly mention Swift that use this thread or use this queue to run this task. And yep.
No, I was just going to say, Gonzalez, we will have, Josh is going to go on in the next session and talk about those differences and provide like actual examples in demo code, which does exist also in the repo. So you can also see that and look at the differences between different types of async calls.
All right, thank you. I mean, I'm usually name my queues, and I handle it very well. So I just trying to look for advantages to what I'm currently doing. But I will wait. Thank you for the info.
Yep. We will definitely be discussing the task groups. Those will explain structured concurrency really well. Yeah, in next talk. Yeah, that's all from my side. Any other questions?
Okay, great. So now that we have that, we are going to go. Oh, I think there's a question from LinkedIn. Hamid, can you go to the?
Yeah, I'm trying to open that. Just see where that chat is.
I can read for you. It says, when it comes to testing, how does one mock the await?
Yeah, when it comes to testing, you have to create a mocker, and with the mocker, you have to use the same async await based pattern using async keyword and await keyword wherever you're testing it in your test code. So it's pretty simple with the testing as well. Like similarly, you write the actual code using async await keywords, you will use the same async await in your test code. There's no need for any extra things unless you have a different logic.
Thanks, Hamid. There is another question in the chat room. Can we cancel async await anytime?
Yes, there is a way to cancel your async tasks. We will be explaining that in the next talks. Those are the part of like structured concurrency and the next talks task groups. We will definitely go over that.
Cool. Thanks, Hamid.
Yeah.
Any other questions,
guys? Okay, great. So if no other questions, we can, Hamid will jump in and just kind of give a quick overview about the code base that we have, and we will do a walkthrough. Now, with that said, just kind of put it in the back of your mind that we do need a volunteer to download that and share their screen and just kind of walk us through what they're trying to do. So just keep that in the back of your mind. Go ahead, Hamid.
Okay, all right. Okay, jumping on instructions for the live coding session. So what's the goal of this live coding session? What we are trying to achieve? So we are trying to achieve the purpose of this session to have our functions to be completed, tasks to be completed in asynchronous fashion. And for that piece, we have chosen some remote calls by making requests to the remote API. We have taken free APIs, freemium APIs from Rapid API that we're using, and we will be making calls from iOS applications to those endpoints. We will have a first screen, where we're going to add the stock ticker, and hit search button. As soon as we hit the search button, this screen will navigate to the next screen. Next screen is going to have all the details of that stock equity. And when user hits top holdings button, it will display another screen, which will be showing up the top holdings list under that ETF, index fund, mutual fund. So yeah, that's all we have. We don't need upgrades or downgrades at this point of time. Now I will be jumping into the code base, what I have, the blueprints, what I already have completed, and what you have to write. So jumping into the code base right now. Okay, so this code base is pretty much ready. Anyone who is going to volunteer, it's going to be pretty easy for him, her, to get started, and nothing difficult, nothing too complex. We have already written all the layers, request makers, request senders, almost everything, errors as well. But we have left a place for writing actual asynchronous tasks, because that's the purpose of this whole coding session. All right, so I will straight jump into the service layer. So we already have a networking piece completed. Request sender is right here. You don't need to write any request sender. You just need to call this, and that's it. We have a request maker as well. You don't even need to call this. It's already being called into the code. It's already being written well. You can just use it. We have errors. Error can be any kind of error. Your request can fail. There can be a bad request. So we also have errors written, well structured in the code. You only need to call these errors or the pieces of this enum based on your business logic. Next, we have endpoints. As I mentioned, we are hitting some premium API from Rapid API, rapidapi.com. We're using two main endpoints. One is fetching stock summary. It has a lot of data, but we will display the minimum data as based on the design we need. Then we have another endpoint, which is the holdings endpoint. This endpoint is fetching top holdings for index fund, mutual fund, or ETF, not the equity, not the stock, individually. So that's something we have ready here. And then what we have are the data fetcher. I'm going into the service layer now. We already have data fetchers pretty much structured. We are resolving data access through our dependency resolver object. You don't need to write it. It's already in there. We have request maker method already all set, ready. It's doing nothing. It's just forming the component and just creating the request for you, so you can make this request into the fetch summary method. So all you need to implement is the fetch summary method, where you're going to take request maker object and just make the call, and that call will actually send the request and will return you your data, basically in form of Swift-based models. Similarly, we have another fetcher right here. It's the same fetcher, same type of structure. It's the only difference is this fetcher is for the top holdings. So right here, sorry, right here, this for the top holdings, and there's a one for the summary. Yeah, we only have these two fetchers. All you need to do is to write your code into this function. Once you complete this asynchronous function, writing asynchronous function, one thing additional you need to do in this session is to go into the view model and right here. Going to the view model already has this fetch code summary function marked as main actor. And here you need to call your data fetchers function here, which you just wrote in service layer. That should be all. You can change your symbols here. You can pass any index fence, ETF, or any other type of equity based on what type of data you're trying to show. If you want to display top 10 holdings, top holdings as well, then you should use index fund, mutual fund, or ETF. You should not use individual equity because equity does not hold top holdings. And if you're only fetching the data for the summary, you should use here regular equity stocks like Apple, Google, Meta, whatever the ticker you want to use here. And if you get confused or if you feel like it's too complex, just look into this helper function. You have to write a similar sort of function. The only difference is you have to call a separate method for fetching summary. It's pretty easy, pretty straightforward. Yeah, that's pretty much it. And before you jump into the code base, I would just share simple instructions. So by default, we have you have to go into this branch, which is named as starter async await propel workshop. This is the default branch in the repo. And as soon as you go into this branch, all you need to do is to download the zip. There's no need to clone it. Just download the zip, unzip your repo, and open your Xcode project. And you don't even need to compile it. It's all set. If you want to compile it, you can, but there are not few connecting pieces available at this point of time till you complete the code in the live coding session. There's a chance it may crash. So you don't need to compile it right away. So just first complete your code, complete the coding session, and then run your code. And then you should be all good. So how the final solution or code or app is going to look like, I'm just going to show right here. So all right. Okay, once you will have your fetchers async method completed, that's how your code is going to look. That's what your fetch summary code is going to look. You're going to have a request maker and object here, and then call the make code summary request method. It's just right here. You don't need to write it, just call it. You should have a do block and then a catch block. And do block, all you're doing is just sending the request and then getting its response and summary response model object. Alongside this one, you have to write the main actor. As you will see in your branch that this code is removed. So you can, but this code is already there, the second function. So you can take it as an example, or you need any reference, just look at this and write the similar sort of code right under this function. Main actor and the function blueprint is already there. Once you complete this, all you will need to run your code base. It's running now. It's taking a while. Okay, so this is a simple UI. You're gonna have put any ticker. I'm using, I suppose, Tesla, TSLA, hit search. You're gonna have this detail screen. Now we have this data coming from those endpoints that the calls we made. And if you go into top holdings, you will see the top holdings. So we're making a different call for this, not for Tesla, just for the purpose to show that we have a separate call as well. So this call is probably for the SPY ticker, I guess. Yes. But yeah, it fulfills the requirement of your session. You don't need a upgrade button. It's right there, but we don't need this. That should be all. That's how your final app should look like after you complete the session. Yep, pretty much it. Any questions? And you don't need to worry about UI. UI is all set.
Awesome, thanks, Hamid. And what we were trying to do here is we were trying to build everything with the exception of what we're trying to learn here. So send me a message on the Teams functionality, and I can take care of that. Obviously, and then the other thing is, now we're looking for a volunteer to share the screen and try to implement this. So let me know if there's anyone who's interested.
Yep, and still, if someone thinks in starter branch, if someone is not even familiar with async await at all, can volunteer as well, because what we have here in the starter branch, we have a final code here. If you want to take an example, don't copy it, but you can just take as an example, go to your test code summary fetcher. It's the exact same fetcher. You can look at this function as a reference. And so the purpose of this session is to make you learn, not to make things complex or difficult. So if you need a reference, just go into final code, go into the summary fetcher, and you can take a look into that, and then you can just go back into your own fetcher and write it if you need a reference. Yeah.
And just the one question that we are getting right now is, right now the starter code. So we created two different branches. One is the starter and one is the final. The starter code, we created a fatal error because we don't have async code implemented there. So once we remove the fatal error and write the actual code, then it will build. However, we do have a final version that doesn't have the fatal code and does have all the implementation available, like Hamid was saying, so that you can compare and see them. Or if you missed the kind of like part of the session or weren't able to finish it by the time this ends, then you can also take a look at that. Okay.
Are we going into breakout rooms, or are we just looking for a volunteer to share the screen?
No, it's better if we do it here and just have it an interactive. If someone has any questions and they want to do it like separately, we can definitely do that in the breakout rooms as well.
Yep, and as I said, there's a final code here for your reference to make it easy. Feel free to look into that. Yeah.
Now try not to
Try not to agree
until we complete the code, just so that
But if you don't know anything about async await, you've never touched it, you can take a look into that. Otherwise, yeah, definitely we are saying not to copy it so you can learn it during this session.
Yep.
I'll share my screen.
Okay. Thanks, Asha.
Can you see my screen?
Yep.
Yep.
All right. So I went ahead and built it and triggered the fatal error. Are you guys able to see the screen? I mean, is there anything else?
Yes, we can see the screen.
Yep.
We're gonna have to make a call. We're gonna have to wait for a fetch summary. But I guess first we'll have to implement the fetch.
Let me share my entire screen. So that way. Let me build this.
Okay. Yep.
Yep, you have to start from fetcher.
You want me to try something here? Like
Yeah,
look
you
for
can. You can. It's gonna crash though. 'Cause there's
Yeah.
a letter. Yeah, you can do that.
AAPL. Well, let's find out where it crashes first. Let's just get the first one done.
Yep.
Sure.
all right.
I think it's Command Shift K to get the keyboard.
Oh.
Okay.
All right.
Yep.
Do you want me to try something? Does anybody wants to steer this?
So you can, I would say start from fetcher, actual fetcher. You have to write a method there. You have to complete that and then call that method in under the main actor. So if that gets complete, you will not see any error while calling it here.
Okay, your fetchers are here in the network layer.
In service, you have to go in service.
Right.
Yep. Data fetchers. And you can pick one, like summary, go for summary first.
Mhm.
Yep.
Does anybody else wants to drive this? Because we are familiar with, like, I'm familiar with this because I have done FT thing. So anybody else wants to?
Yeah, I mean, Joe, you were on something. Do you wanna?
Well, I believe we have to make a network call here, and I would probably call some service. Well, let's say await for some service.
All right. What service are we calling here?
Hamid showed us earlier on the left side, there's somewhere there's a service mechanism.
This is kind of awkward.
So you have to actually, have to make a request maker object first, initialize it, because you have to pass that request maker object into send request. So create a request maker first, so you can pass into the request when you're sending it.
Okay. So should I do like a make code summary request? Like a code summary?
Yes, you have to. We have request maker. You can create its instance, class.
Code
Yeah.
summary request equals like
You have to initialize. We are using dependency injection concept. So just don't initialize it. Just declare it request maker instance, because since it's conforming to the protocol.
okay. Sorry, there's a lot of background noise here.
Yeah, you're going right.
And just make it as a
Request maker. We have request maker. If you want to look into that networking, we have
Okay.
it. Yep.
all right.
Yep.
So we're going to send that to, if we went to networking request sender, and find out what there's probably some kind of call to be made there.
Yes. Now you have to initialize it.
Okay, and initialize it as
You basically, if you look at the function, make code summary request function, it's returning the request maker. So you can initialize
okay,
it.
I can just get the response from that. Okay, got it.
Yep. Yep. Yep.
And that would
Perfect.
be a symbol value, correct?
Yep. Yep.
All right.
Yep.
Oops, where did I go? Did I undo that? I'm sorry.
Just go back.
Go back, just go back.
I think you
Yes.
made a typo in the component when you're trying to line 26.
It's a different fetcher. The other one,
Quite a
Sunday
different
fetcher, the right one.
Yeah, there you go. Okay.
Line 27. Component name is messed up.
Can't find URL component.
In
Line
27, in 27,
27.
yeah, that variable you change it to component.
Oh, did I?
Yeah. Yeah.
All right.
When you went to go grab the function, you nudged it.
You go. Okay. All right.
Yep.
Can't find make and scope.
Now you have created the request.
Mhm.
You will send this request now. And for the sending request, you have to use send request function, which is an async function.
Okay.
Request sender, it's on your left there. It was under networking folder. Request maker and request sender.
On networking, yes.
There.
So what are we going to do here? Send request to that.
You have to call this one.
You need to call this one, right?
Yep.
All right.
Is it a static function or an instance function?
Let me check. Request sender is a request sender. Okay, I need to instantiate this.
Yep.
And I do encourage everyone to do this also in the background. You know, you do have a copy and just work
Do we
on-
have a URL to
So you don't need to initialize it since we are using the concept of dependency injection here, conforming to protocol. You don't need to initialize it. Yes, just declare it. And now the next task you're going to do, since it's async and there is it can throw error as well, you have to use do catch blocks now for the rest of your task execution.
Okay.
Now sender dot, you have to access the function. Yes.
Sender.send request and then send the make quote summary request. Okay, and
Yes.
do a try here.
Since this is now returning and a type, if you look at the send request, what it's returning a response which is a model. So you have to initialize that value to the model variable now.
Okay.
Just like it was a synchronous method, right, Hamid?
Yep,
You just set it equal. You say my response equals this.
Yes, you have to put, for asynchronous function, you have to use try await as well because it throws and await for asynchronous. Yep. You can do that. That's fine. You can do let and then
Equals try.
Oh, wait.
Yep.
Wait, and then this, and then there's a catch here.
I think you're making a mistake here since we are using the protocol type to the dependency injection mechanism here. So use the protocol, instantiate with request sending, not the request sender.
Can you repeat that? Sorry.
So can you initialize, declare request sending type and not the sender, since it's yep. Yeah, here request sending.
Yep.
Now you call that method. Sender dot.
Mm-hmm.
Could you just make an instance?
Model could not be inferred.
Yeah, you have to call like just call it again, sender dot send request. Yes. Now pass your maker to it. Yep.
Are we going to catch the error here? Like, do we?
So do block. Yeah, you will catch error in into the catch. but you have to finish up do first. So once it returns the object of that model type, you have to return it as soon as execution completes.
All right, it's still throwing me an error, so I'm gonna try and.
Yeah,
build
you
it.
have to
specify
return
the
it.
type in the after the response. You need to specify the type.
Return response. Response. Yep. On catch, we have different errors.
I think we need to specify the type here, right? Or do we need to or
Right,
not?
right. You need to
Yeah,
specify the type
yes,
there.
specify the type.
Um,
It's a summary.
Summary response.
Yeah, summary
Yeah.
response.
all right.
You shouldn't need the declaration of the sender on the line 23, right? It's just an instance variable. Request sender is a property that gets
You want me to
initialized
do
by
it
a
like
resolver.
this? You want me to do this?
I just don't. I could be wrong just doing this on the fly, but I think line 23 just doesn't need to be there at all.
Like this?
Yeah, and you need to
No,
go
you
back
can't.
to request sender.
You can't use directly request sender since we are using that dependency injection concept. So the protocols have default implementation. Whenever you call a method from a protocol, then wherever the protocol method blueprint is implemented, it's going to call automatically. So that way you don't need a lot of implementations. That's a concept of dependency injection. So you have to use instance of that protocol, not the instance of the class.
Yeah, but that's defined in 14 already.
Yes, right. That was
That's what I'm
injected
saying. Yeah.
in that method. So it should just be using request sender from line 14, right?
Yeah.
Oh, we have one here. Okay. All right. We don't
Oh
need.
yeah, it's there. That's it, right?
All right. So
So just like try await self.request sender, right?
do we need a self here?
No, you don't need it.
You know,
Print there.
all right. Or do we need to return missing return instance? So it's expecting a summary response. So I guess.
No, you have
Oh,
to
it
throw
also
it.
throws. So
Yeah, I don't need
Error
to
doesn't
throw.
return
I don't
anything.
think.
Yeah, that's error. You have to throw it. Once you throw it, throw is a type of return. That's it. Error will go away. Just put throw before the print.
throw a print.
Do we need to print it at all? Okay, let's do it through. All right.
Is it gonna work? I don't think so.
Yeah,
You need to initialize the error.
You can use the errors we already have. You just type Yahoo Finance service errors. Just type remove the error. Yeah, Yahoo Finance. We have an enum. Yahoo YH.
Oh, YH. Okay, Yahoo.
Service errors. Yep.
Error dot.
Then use
Summary fetching.
fetching
reason
error. Yeah. Get the error here.
Okay, cool. All right.
Yep.
Should we build this?
Yeah, this piece is complete for you. No, you have to write. You have to call this into the main actor.
Mm.
Yeah.
All right. Where did it fail? Mm.
That
Do
one?
you remember where it failed?
UI.
Should I build it and does anyone remember where it failed?
Yeah. Does it fail? Really? I don't see an error.
And I'm going to build it to trigger that error so that I can. Sorry
Yeah,
about
that was in the search bar view model on the fetch quote summary, I think, was the first place it fails.
Pardon me, can you repeat it?
In the search bar view model on the fetch quote
okay.
summary function.
Search bar view model. So this is response model.
It's up under UI.
UI
Oh,
components search bar.
Search bar, I see a dashboard, I see.
Components, yeah.
Search bar.
Search bar.
View model.
That's- So yeah.
A view model.
Oh, in
Here's-
the
yeah, in the view model.
Yeah,
Now,
fetch
this is
summary.
the main actor. Yeah, that's where you have to call your async, use your async function you create in data fetcher. You don't need to mark it again. That's already there.
Oh, it's already there. Oh, yeah, there it is.
Yeah.
Okay, got it. And what am I calling?
So you can use two things here. First, you have to use load state. We have an enum based on where the execution of the async function is. Based on states, you will use the load state, and then the actual async function will run into the task block, because that's how the main actor will take that asynchronous function. It wants it into the task block, but you can set load state as soon as you get into the function.
Okay.
Yep.
Load state and then followed by because I'm
Equal
not
to just to
sorry.
it's an enum, just equal to, yeah.
uh-huh. And
Dot.
then
Look at the code below you, the fetch image function.
Yeah,
That's
exactly.
that's the pattern we want with our
oh,
own.
okay, this one, the same pattern.
Yep,
Yeah.
yep, same pattern.
Oh, okay, got it. Load state is loading. All right, and then so this is going to be
You have an instance of something, a data fetcher or data fetcher holdings.
so data fetching for holding. So what is this? What are we trying to call here? Why of code summary fetching, right?
Yep, yep.
Dot fetch summary and
Good. You can
where are we getting
like,
this?
just pass literal here. Just type TSLA, hard code it.
Oh, okay, for now, okay.
If yeah, for now, I think you can do that. Yeah, for now you can do that.
All right, okay.
Okay, hold on. Can you scroll down? No, you don't have to. You just give search value. Sorry, my bad. Give it a search value since we have a UI. Yep, search value.
All right, there you go.
Yep.
These are not top holdings at line 31.
This is, what would we call this? We'll call this
Code summary.
code summary. All right.
Good.
Well,
It's a
Okay,
question.
Yeah, you need to implement this too. Two different calls are being made. So yeah.
all right, okay. So we go to
So read the question. Go ahead.
Yeah. So in the view model, when we use the main actor keyword, so all in this function in the fetcher, for example, we use in the fetch top holdings of the fetch summary, you use the async and the throws keywords. But when you use the main actor, you don't use that. You use a task instead. That's where I guess I'm slightly confused.
So when you put the main actor, Swift, when this function runs, you don't know. Let's suppose system don't know what type of function is this, what kind of a queue or thread it need, either is user interactive, either is a background task. So when you put the main actor, by default, if it's UI based task, it's going to run into the main thread. Otherwise, Swift will decide itself, async will decide itself that what type of queue it's going to take, if you take into that sense.
But what about the keywords itself? So it seems like you don't say async for the function, right? When you have the main actor and you're calling fetch summary, you don't say async in that same line. You use task instead.
You don't need to use async word for the function that you're marking at the right main actor.
Okay, so when you use so it's just a syntax difference than if you use main actor. Okay.
Yep.
So is it why of code summary request maker
It's fetching one.
Top holdings.
fetching, right? Or
Yeah,
top
top holdings
holdings, it's top
fetching, yep.
holdings.
Yep.
And the reason is
Top holdings response. That's the model. Yes.
Wait.
I'm getting lazy, so. Right.
It's duplicated, I guess. Return twice.
Ah. Oh, I did not do a try. What did I do wrong here?
Yep. So looks like that method is can you go to that method, make code top holdings? Yeah, remove throws from here.
Yeah,
Remove throws from here. Yeah, that was extra bit. Only throws.
you don't need throws.
Yeah, just remove it from here, and now it should be good. Still may crash. I think you need to implement the top holdings. Oh, okay, it's there. Oh, it's there. It's there in the view model. Okay, all set. Should be good now.
Right?
Well, you don't have data.
Yep. There you
Oh,
go.
you have it. Okay. Then you have two calls made. So you can make two different calls for the sake of this session. There's two calls made back to back, but normally two calls should not be made back to back. So if you go into top holdings, 10 holdings, you will see all the holdings. Yes. So it's a different call, but they were made back to backs. That's why you had already data when this detail screen loaded. But I would recommend do not make back-to-back calls.
Was there a delay in the UI update for whatever reason, or was that just something?
Yeah, it's maybe the response rapid API was a bit slow sometimes. Yeah.
And we didn't miss a main actor thing, you know, like if it wasn't on the main thread, it didn't get updated.
Did we miss main actor? I don't think so. Did we?
Is it working now or so? Like, can you go back and enter a new thing and it will come up?
Just
Yeah.
type, yep, Apple, maybe different one. APL.
AL.
APL.
Oh, yeah. Sorry.
Yeah, bingo.
Yep, that's it.
You gonna give us our time back?
Sure.
We're good. That's it.
Yep.
All right, I'll stop sharing.
Okay, great. So
Thank you, Usha.
just thank you so much, first of all, for sharing. This is exactly what we're trying to do, right? Making sure that everyone is engaging and everyone's participating. So just from the others that weren't engaging or talking as much, did you download it? Did you work on it? Did you find any struggles or any issues before we move on to the next segment? But just want to open it up to see, what others thought. And if you thought it was easy, just general thoughts for now.
I can go.
did it along. Oh, sorry. I was going to say, I
Go
did
ahead.
with Usha, and I really, really appreciated that because I haven't had to implement it yet. And I'm super eager to get to how we convert from combined to this. But great job, Hamid, and thanks for setting this up.
Yeah, awesome.
Awesome.
Any other comments, feedback? Bam, I see your hands up.
Yeah, so I was able to complete the project. Wasn't too difficult, but I did have a question on how it's supposed to be written. Can I share on my screen?
Absolutely.
Okay. One moment while I share the right screen. Sorry. I have a large monitor. Okay, can everybody see my screen?
Yep.
Yeah.
Yeah.
On screen. Okay, so I know there's a better way. I'm sorry.
That's a very large monitor.
Oh yeah, it's very big. Sorry. I hope you can see it. But like I wrote it kind of in a very short way. But what's the advantage of writing it like this, where we don't get to see the error and we're not like capturing in like a task and then doing a do and catch? So is there any specific advantage of writing it this way versus just returning the try wait?
It's two things. First, you're trying to organize the code, organize the structure, the architecture of your app you have. That was the main reason I structured it like that way. So it could be clear, easy, concise, and anybody can understand it just by looking at the code base. That was the first thing. That's how I organized it. Second, you can use task block with the main actor. And if, as per the best practices, you should use the main actor into the view model, especially with the Swift UI. So instead of putting the data fetcher, where you only have service, we are not definitely putting main actor kind of stuff, which is more tilted or diverted towards the UI based tasks that are being performed. While you handle all the business logic in your view model, that's a place where you should use main actor, because your logic falls into the view model, not into the fetcher or service layers. If you look at the best practices, I mean, you can do it. There can be hundreds of ways to do it, honestly. But to keep the code base more structured, well organized, easy to understand, maintainable, that's why how I structured it. That was the biggest reason. Yeah.
Okay.
I also think, yeah, in this code here, I don't, correct me if I'm wrong, but I don't think you're capturing errors in that code.
Yeah, I think you're right. So I mean, it's throwing an error. So
you will capture error if there is an error. It will only go into the catch block, then only.
It's not throwing an error here, right?
Yeah.
You're not doing it through, you're not catching it.
That's true. Yes, that is true. I figured the error will get pushed down. So when you call fetch summary, the error will get caught here. But yeah, I think you're right.
Yeah, I think if the request sender is throwing an error, then it will propagate back, or the request maker. I'm not sure.
It will propagate. I will say that sometimes you want to catch your errors inside the fetcher, just so you can map them to your own error structure.
Errors, error, whatever definition,
Right. Yep, I think that's a really good point. And honestly, I just wrote it this way just to be very fast. And I do think the error will get passed down to the view model, but I think that's a good point. We want the errors to be captured right where it happens. Okay.
Map to something that makes sense.
Yes, exactly. Okay, cool. I appreciate it.
Thanks, Pam. And I see Usha has a question.
Yeah, I don't know whether it's for this demo purpose that we fetched the data for the holdings earlier than instead of when we hit the button, right? We could have made a call then. Is it just for this demo purpose that we made both the calls?
Yep. That's why I said we shouldn't do both calls back to back. If you look at the one of the UI pieces, you will see that the back-to-back calls are being made just for the session purposes. We created this code base. But technically, I would recommend like do two different calls first when your detail screen loads for your stock details, and second when you hit the button to uploading, you should make second call there. That's how it should be. If you want to make it more like more organized or a better approach, best practices.
Yeah, great. We did have a question from LinkedIn saying that Thomas downloaded the project, but he wasn't able to run it because he's using Windows. Sadly, Apple does limit, Swift in Xcode only. So which means that you are required to have a Mac. You can't run this on Windows. Okay. Any other questions before we take in a quick break?
A question, sorry. I know you were saying the trend is to go towards use of async await. Is there any situation where you would not use it and go back to completion handlers and things like that?
I would never go back to completion handlers.
True.
I can think of one, and especially because here at Fidelity, we use a combination of the old UI kit and Swift UI. There may be use cases where we need completion handler in some cases.
I don't have support. If you have like iOS version which does not support it with full features, then definitely it's a good idea to stick to the old technique. Yeah.
For me, one of the things I can think of going back to completion handlers, and correct me if I'm wrong, async await, you have the UI doesn't update until it's completed, right? Whereas completion handlers, you could show like the Facebook shimmering thing, and as the data comes in, you just populate it. Whereas async.
Sorry to interrupt you, Raj, but we can actually do it in with async await too. We have it actually implemented in debit card, a shimmering. You can go and take a look at it. I think many features have it right now.
Oh, okay.
Yep.
So you don't have to wait for the call to complete to.
Yeah, we can do a shimmering, and then once the call completes, it populates. Yes.
Okay.
And you're going to listen more in the next talks where we have structured concurrency, async let, so that will also clear up the mind of async await in more details.
Okay.
Yep.
That's real neat that there's no completion handler. You don't get your response on the completion handler, which is way down there. It was just you assigned it. You just said let response equals, and yeah, simpler.
Yeah. So yeah, definitely targeting the older version. That's one of the flaws that async await has. It doesn't have backup support. And Hamid did show at the beginning the list of the supported versions and whatnot. Yeah.
I had one question. If you want to set priority in your API calls, like if you have multiple API calls, you call it one after the other using dispatch groups. Usually, can you do it with task as well? Does task go well with dispatch groups?
Yes, tasks do have priority. They're slightly different than the way it works with dispatch queue, but yeah, you can assign priorities to the task groups.
Okay, that's good.
Yeah.
Okay. Any other questions?
I'm guessing one question that comes to my mind is pretty much with Combine, they have this operator that is .zip, which is pretty much waits for multiple data streams. And then it syncs it all at once. Can you also do that with async await, with the try await? That can you put like multiple back to back? Like different, can I do like try await function 1, try await function 2, try await function 3, and then like is the logic going to be so that it's waits for all 3 to finish, and then it runs different what is below?
If I think I want to answer that, if I can, if I know what you're asking, I mean, if you're calling function A and waiting for the result, and then you're calling function B and waiting for the result, and then you're calling function C and then waiting for that result, and then returning like the final result. Is that what you're saying?
Or like
one right after the other?
Not after the other, but okay. So right now, I'm using Combine zip operator to synchronize async functions so that once it all finishes, it tells me, okay, all the async functions are finished. Here's all the values. They cannot do something similar with async await.
Oh, you're using like a zip kind of thing?
Yes.
Yeah, that's a synclet that'll be coming up shortly.
Yep, exactly. Yeah, we'll talk about that in just a minute.
Yeah, see, it's kind of like we predicted the questions and we kind of build up the session based on it. Okay, great. And this is coming up in the structured concurrency talk.
Yeah.
Okay. Yeah, any other questions? And please don't hesitate. We still have a few minutes dedicated, 10 minutes dedicated to this. So if there's any questions, feel free. And that, again, that's the whole point of being interactive, is that we didn't want it to just be a lesson. This is what you need to know, and then that's it, right? The fact that it is interactive, asking questions and trying to understand, that's what makes it valuable.
I had one more question, Nader. How does task handle the self? Like we don't do weak self in task, right? How does it handle that?
The way tasks work, it's basically a strong capture. And so anything that you're capturing self inside of there, I mean, it's going to stick around. There's really not a good way of doing weak self inside of that.
Okay.
There's some other things, and I think Josh will also be talking about how tasks can be canceled and whatnot in another talk.
Okay, I'll wait for that then. Yeah, thank you.
Morali?
Yeah, I have a quick question. Just for testing, I removed this main actor here to see what kind of runtime errors I'll get. So I'm getting, I can use receive on. So is there any other alternative than using main actor? Can we use receive on here or no?
So that's why the main actor, it was on that function, is that function is going to be updating published values in that view model, and those need to happen on the main thread. So you were pretty much on the main thread up until you got to that first await on line 30, but you're not guaranteed to be on the same thread afterwards. And so it's went to the background. So if you put the main actor back where it was, like on line 26, then it's going to do the await, and then when it returns, it is going to switch back to the main thread for you automatically.
Yeah, and I guess
think-
receive on is one of the publishing operators. It falls under combine, I believe.
Yeah, Morelli, all Michael's saying is the main actor's working out of convenience for you, right? So the question you really got to ask is why would you not, if you know you're doing async await stuff and you know that this may update your view, why would you not want to mark it as main actor?
Well, I think just to solve this warning, you can just dispatch to main, and that will solve the issue.
Yeah,
But how about
ugly?
Well,
yeah, but
go ahead.
my question would be, I'm sorry, what about overwhelming main? Because overwhelming main will hold the UI, correct? So if we put main actor, and then we have 30 frameworks working together, how it will work? It will hold hostage the UI, or
No,
it will
because it's
just by
operating within
magic?
It's
Okay.
operating within a task. I mean, that's why that task is wrapped around that stuff. So that's a separate entity that can be suspended, and the main thread can keep going.
Okay.
It's doing it asynchronously.
Yeah, it's just saying when you're done, you need to hook that back into that main thread to update your UI.
Yeah, and your thread won't be blocked. Your system can context switch and can schedule any of the tasks to the same thread. So and as soon as awaited function completes and return, your actual function will resume. So technically your thread is not blocked.
Yeah, we got used to that with closures where you'd have to put dispatch main thread because I'm coming up back to the UI. Dispatch main thread. Oh, wait. Yeah. This totally takes care of it.
It is doing things asynchronously in a synchronous way.
I just posted some code in the chat. So I think so you can use await main actor.run and to run something on the main thread. I don't know when we would want to choose something like that, and as opposed to just using the at main actor tag. Anyone have an answer on that?
The biggest problem with doing that is you're going to have to do it every time you want to update the thread. So if you look back at the original code, we've got one section of the code up there where we're saying, do this, try this, get a result, assign it to our published value, right? But that can also throw an error. So if we go down to the error paneling, then now we're back to another part where we're going to want to update the main UI, but with an error message. So then you would have to mark this spot saying, hey, I want to update the main thread, and go down here and say, hey, I want to update the main thread. And basically you're doing what Swift will do for you if you just annotate that function with main actor. So it just cleans up a lot of stuff that you would have to write yourself. And that's kind of the point, is getting rid of all the stuff all the cruft, and just lets you get down to, all I want to do is get this, I want to get this, and I'm done.
I have a comment. I wonder if, as a general rule, can we think of it like this, where the main actor in the app, we should only have one main actor acting at the same time? Is that the most safest approach? Because, for example, I could see somebody creating like a for loop and then having a task being created in each for loop. So now you have, thousands of tasks that are updating on the main thread. Is that your opinion, you think? Well, anybody can answer this, but maybe one actor should be acting at the same time only once. Does that make sense?
Trying to visualize it.
That would depend on whether or not you're wanting your UI to update every time.
Exactly.
I mean, if you're loading 1,000 objects to a list and you're wanting your list to automatically update, then you're going to have to go back to the main thread anyway, right?
Right. But like a smarter way to approach that is to create a function that does all the work, and then when it's done, update the main thread. I wonder if the compiler will know that when you have all these tasks, maybe the compiler will try to put it all in one thread instead of having like 100,000 threads doing concurrent tasks and then trying to update the main thread when it finishes.
Yes, groups.
That's great. There you go. That's how we used to do it, right? So
yeah, that's coming up. Like Josh said, there's task groups coming.
Okay, cool.
I have like a question regarding the load state. Aside from using load state to check the state of the current task, is there any other way to recognize or check whether the task is still on progress?
I mean, there's a lot of the ways to represent your UI. It's just that with a load state where you can sort of say, hey, I'm in error mode, or I'm loaded mode, or I'm in loading mode, you kind of eliminate the chances of having multiple states that you're trying to condition off of. If you've got a processing flag and I've got an error message and I've got my loaded data, you're going to have to write code trying to figure out which one. Oh, if error, then no, wait, if loading, if I have an error, how do you organize that? But if you have a single state for that, then it's pretty much easier. I'm in this state, or I'm in that state, or I'm in that state, and you can just switch on it.
Got it. Thank you.
Any last minute questions before we take a short break?
Oh, I just have one follow-up question. So on the same main actor thing, so if my class has all the functions, so in our example, can I mention the whole search bar view model as main actor? Because the two functions inside search bar view model handles updating UI. Right? Is that a good approach?
But not making the request, that little request maker thing, that's not a main actor thing.
Okay, wait, let me share my screen again.
Yeah, you can do that. I tend not to. I tend to only mark things main actor that need to be.
So yeah, so this way, the runtime errors are gone. The UI is getting updated. My question is like, these are the only two functions this class has, right? So instead of mentioning main actor on both of those functions, can I put like on the top of the class here? Or is it a good approach to follow?
What if you have helper methods, different other business logic that doesn't require main actor, doesn't switch to the main thread? So
yeah, in that case, that makes sense. But here, right now in this view model.
Yeah, the only thing I don't like about that is that you're pretty much saying that all of these functions need to be called on the main actor, which means when you create that view model itself, that has to be created on the main actor. So you can't really do it as a separate function because your initializer is now marked with main actor. Every piece of that is marked as main actor. It can cause that main actor thing to start propagating through your entire code base.
Exactly. You could unintentionally paint yourself into a corner wondering how you got there, and trace it all the way back to, oh yeah, I thought I was going to save time by putting it here instead of in two places down here. So as a general rule, I wouldn't do it that way.
it seems thread is going to be more busy with the main actor all the time, back and forth.
Let's take a quick break and we'll be back at 2:42. Can start. Josh, the floor is yours.
Perfect. Okay. Thanks, everybody. Hopefully you got something to drink. I went and got me some nice fresh ice water. So I'm I'm feeling good. Hopefully everybody's feeling good. Let's dive into it. perfect. So I want to take a few minutes, talk about, what came before, how we got here, what the different options on the table are right now in the Swift environment. So you've got closures, you've got combine, you got async await. Now, just want to cover a couple of things real quick because I play a little fast and loose with what some things are called. So please bear with me. This is kind of a letter versus the spirit of the law type situation. I realize completion handlers are closures, but closures are not completion handlers. Those are different things. Also, I realize Swift combine is a form of reactive programming, but there are other ways of accomplishing reactive programming on iOS and in Swift, looking at you, RX Swift. And finally, Swift concurrency is a big box that holds a whole bunch of different things, tasks, task groups, async let, async await. So if I slip in and out and I just refer to it as async await, I'm really talking about all of Swift concurrency as a whole. Excuse me. Okay, so how did we get here? Well, Swift was released in 2014, had full support in iOS 8. With Swift and coming to iOS, that's when we got closures and completion handlers that replaced the delegate pattern we were also familiar with. And when all you have is a hammer, everything looks like a nail. So we started using closures and completion handlers for everything. As a result, we got nested closures, and it's a tricky situation. So jump to WWDC 2019, Swift UI gets announced, Combine gets announced alongside of it. Combine is what powers Swift UI. It is, excuse me, that is Apple bringing that reactive programming language to programming paradigm to iOS. But alongside of the Swift UI piece, they also brought the behind the scenes power of Combine and made it available to everybody. Now, we're talking about async await. And depending on what programming languages you used or have used over the last 10 years or so, you may not know this, but async await was popularized, but it wasn't originated in 2012 in the C# programming language by Microsoft. So for 2012 to 2020, other languages started adapting it, integrating it into their systems. And Swift is on the kind of tail end of that whole experience. So Python and TypeScript added it in 2015, Kotlin added it in 2018, Rust in 2019, and even C++ in 2020. But Apple eventually got us caught up, and in 2021, they gave us async await. Hamid mentioned this earlier, but there is limited support for async await in iOS 13, but you don't get the async await API support like you do in iOS 15. So it's not that you can't, but you are gonna be swimming upriver a little bit if you're trying to do async await prior to iOS 15. Okay, so let's talk about closures. This was, again, the first new approach after the delegate pattern that they had in Objective-C. It came on the scene in 2014, and so it supported by the most third-party libraries, everything goes back to 2014 iOS 8, right? Closures and completion handlers are part of the base functionality of Swift, and as a result, they power a lot of Apple's APIs and a lot of third-party APIs as well. When you use a completion handler, you've used it so much, you've seen it so much that you know how to use it. It's very familiar. You've got 7 different ways you can structure it, different ways that you can code it, you know exactly which way you like the indentations to work. You know it, right? So there's a certain comfort that comes with that. Unfortunately, it was their first try at this in the Swift language. And so, as with a lot of 1.0 products, there are better applied, more focused solutions that have come later. Nested closures can get really sticky really quickly. It's difficult to understand what a nested closure does, how the different pieces fit together. Testing a nested closure or modifying a nested closure and accounting for all of the things that are going to come as a consequence of a change you make can be difficult. And the thing about completion handlers is if you forget to close that loop somewhere, it can be really difficult to trace down which path you got on that you forgot to close, and now you've got some weird edge case bug that is difficult to track down. So Combine comes on the scene, excuse me, and in 2019, and it brings a whole new set of tools to the Swift language. So Combine, again, it powers Swift UI. You can use the kind of a default publisher, subscriber, mark something as at published, and it works really well with kind of a minimal amount of effort. One really good thing about Combine is when you set a subscriber to watch that publisher, it's not going to miss. So if that change happens, it's going to get emitted, subscriber is going to catch it, and it's going to do whatever you've told it to do. Again, as you start to get into some of the trickier, you start writing your own custom subscribers, publishers, you have to make sure that you're sending that message as you're doing that all by hand. So Swift UI does a lot of the heavy lifting, but again, as soon as you get into that complexity, you got to get real rigid and make sure you've crossed all your T's and dotted all your I's. I've heard it said multiple times over the years, people are just kind of scared to get into Combine. So I understand there's a lot of jargon that comes, keywords that come along with Combine, but it really is a matter of just understanding how Combine works. Kind of have to change the way you think about your problems a little bit. We actually have a talk we did a few months ago for InRhythm all about understanding and kind of an introduction to Combine. So, and humble brag there, but you go ahead and go and take a look at that. Another tricky thing of Combine is understanding how it plays well with closures and completion handlers or with async await. And so if you stay in Combine land, everything makes sense. When you start to branch out, you can start to run into some problems. And lastly, Combine was the new hotness, but it's not the new kid on the block anymore. And so the new APIs that Apple's coming out with may or may not be written in or support Combine directly. It may not be getting the frequency of updates that you're used to seeing if you're a common user of Combine. So now let's talk about what we're all here to talk about: async await Swift concurrency. So again, really new, 2021, iOS 15. It allows for, like Hamid said, the last is going to be a little bit of a review, but powerful parallelization of code, right? Every year seems like Apple throws in 4 more cores for us to use on our devices. And if you're using one app that's using 1 or 2 threads, are we really taking full advantage of that powerful device? And maybe not. But with structured concurrency and async await, we're taking advantage of that newer, greatest hardware. It's really good because it works like other languages. So if you're coming from other languages that used async await, you're already familiar with how it works. Additionally, the newest and latest and greatest APIs coming from Apple are going to be written with async await in mind. And as you'll see in a minute, we'll get into it a little bit, but it can be easier to understand just because of the way that Apple's implemented some of the coding structure to async await. It can just be easier to follow what's going on, especially if you're coming back to code you wrote a little while ago, or you're coming to code that you didn't write that you now need to try and understand. It can be easier to follow exactly what's going on. You don't have to kind of draw as many connecting lines. Unfortunately for async await, it is the new kid on the block. And so not all of the APIs are going to support async await out of the box. So you may have to work around that a little bit. And additionally, if you're in a situation where you're stuck supporting 3 generations of iOS ago, you're going to be limited. So the nice thing about iOS is, the adoption curve stays pretty good, stays pretty consistent over time, and time moves forward. So the minimum is iOS 15, and we're past that now. The last thing is, while async await does a lot of things for you, it's still not foolproof, right? You can still make bad decisions and do bad, unintentionally cause problems. So if you really do want to understand how it works, not just get it working, to try and avoid those situations. Okay, so I want to just take a couple minutes. We're going to do some side by side. So I'm just going to briefly go through, closure versus combined versus async await. Okay, so you can see telltale signs that this is closure with a completion handler, right? You can see you've got your escaping value, or in this case, tuple. And at the end of it, we return our result with whatever that result's going to be. Here's a full example of that closure in a method that we're querying, looking up food information. You can see we make the URL, we establish the URL session, pass it the request, we decode the response, we check the response. If the response is good, we decode into an object, we return the object. If we don't get the response back, we throw an error. If we can't decode for whatever reason, we throw an error. Everything is there, you can see it, but it is awfully verbose. And so let's take a look at combine. So telltale signs of a combine code. You've got that any publisher there at the end of the function definition, as well as, you can see down here at the bottom, you've got what I like to call the combine magic, the dot map, the dot decode, the dot map error, dot erase to any publisher. So you can see same pattern here. We're taking that URL, we're creating the URL session, passing in the request. It's a little bit easier to understand what's going on here because you got a line at a time, right? We're mapping that response that's coming back. We take the value from the response, we try to decode it. If there's an error, we try to understand what that error is, and then we return the value. So it's a little bit easier to understand and kind of read through what's going on here than what we had with the escaping closure. Now, again, this is a bit of a review from what Hamid was saying, but if you take a look at it, this is an async await function that is also capable of throwing an error. You can tell, get the async throws. At the end of it, what are we going to return? We're going to attempt to return a decoded value. Now, this is what I'm talking about when I say it can be easier to read. We're doing all of the same things as we were doing in the last two functions. However, more things are fitting into a smaller area. Your path is exactly the same. Your URL request is the same. But it's when we get into this URL session where things really get clean, really get easy to understand. You can see we're making that URL session, passing in that request. When it comes back, do we have the data? All right, what's that data? Can we decode it? If at any point the URL session throws an error, that propagates out. If when we try to decode that JSON throws an error, that propagates out. So we mentioned a few minutes ago, you may want to handle it here because you know more about what's going on and you may want to track that information a little bit different. But in this particular case, we know we had something go wrong. We're just going to propagate those errors out. Okay. Quick side-by-side. Really, the point remains. You see, as we go further back in time, it's more verbose, more stuff going on. But like I said, just a picture to articulate a little bit what we were just talking about. We start to use async await versus combine versus closures. What you notice is the functions themselves get a lot cleaner. But when you start doing things that leverage one response, relies on that response before it goes to the next thing, that's when the real cleanliness, clean power of async await really starts to show up. You can see here as we take and we're combining the results of one function into the results of a second function. So in this example, you can see we're passing in a food name. We're going to go and get information about that food. When it comes back, okay, we're going to create a list of results from that. We take the first entry in that result and we take the category from it, because what we're looking for is we're saying, all right, this first entry that came back, let's get a bunch of food that's related by category to this food item we just found. So you can see as we move from this initial call, now we've got this in this closure here. Inside of here, again, we're having to call dispatch queue main to update the UI. In here, we're having to do a similar thing. And all the while, if this request fails, where do we handle that? All right. If this request fails, where do we handle that? Well, if this response comes back, but the category isn't set correctly, well, now where do we handle that? So compare that to our combined example here, and you'll see, a little bit cleaner, same idea, okay? So we do our first call, we map that result, see if we get the category. If we get the category, great. Now we're going to query the food by the category. If that works, great. We'll map that. Otherwise, right, we're going to just set the results of the meal, the initial value. We don't do anything with category. One thing you'll notice here, though, is combine does get a little tricky. It gets difficult to understand, especially if you're not familiar with combine, right? You got this, oh, I got a dot sync, now I got receive on. What does all of this mean? So I can understand why it can be a little intimidating to folks that are new to it. But we'll just, throw the gauntlet down here and say, here's our async await doing the exact same thing. So we take our async await, we query the food by the name, we get our results back. Then take that category, does it have a category or not? Pass that into our query food by category. If at any point anything goes wrong, we catch that error, we handle it. And otherwise, what are we going to do? We're going to take that, we're going to set that results by category, and off we go. So again, just to kind of show that contrast between the three, there are a lot of ways in which async await is making life a lot easier for all of us. Okay, so in conclusion, it's important to understand you're using the right tool for the job. It's as important to understand when to use the tool as it is how to use the tool. So, are there cases where you should still use closures? Probably, right? If you need to support the largest number of customers, you're doing a third-party API and you don't really know what everybody's doing, and you want to make it easier to use, or you want to make sure that they can go back to iOS 8. Well, that's closures for you. On the other hand, if you're a little bit newer technology, and this gets to the zip question with combine. If you're taking multiple responses that you got this call comes back, this call comes back, this call comes back, and at the end of it you just want to mash all that together. Well, there's a way to do that in async await and with task groups, but now you got to think about it. Now you got to look at it. Async await isn't the perfect solution for every problem. So there's still reasons to use combine. Additionally, if you've got a situation where you've got multiple subscribers are coming back, and forgive me, if you've got multiple subscribers subscribed to a single publisher and you want everything to react in a certain way when that one response comes back, you know what? Combine may still be the best option for you. But in general, if you don't fall into category one, where you got to get that largest support or older software support, you don't fall into category two, where you're doing some of that specialized stuff with combine, you should probably be looking to async await. It's easier to write, it's easier to test, it's easier to maintain, and in a lot of cases, it's easier to keep track of what's going on and understanding what's going on. So I've included some helpful links here. We've got the Apple Combine documentation, getting started with Combine, and is Combine dead? Additionally, for the async await, getting started with Swift concurrency, which we'll have some more information on in a little bit. The material from previous in this, and in a few minutes, talk related to async await and Swift concurrency, as well as I've included one final thing, async await in Swift, explained with code examples. These are all resources that I bookmarked before I did this talk. I referred to them, check my understanding, make sure I'm not losing my mind. And then, so again, we did do a previous talk for InRhythm, talks introduction to combine, goes into the various pieces that make it up. So you can look back at that. And I believe they put a link in the chat for that as well. Does anyone have any questions?
And just before questions, I just want to add that there is in the repo that you downloaded at the beginning, a lot of those code examples are actually there. So if you want to take a look at them and play around with them a little bit, you can definitely do that.
Yep, that is correct. There is this project here. It's inside the main project folder. It's called Async Combine Closure. What we have here is, and we'll go through this in just a minute. You can actually see the side-by-side and step through the side-by-side of that same network call happening in the 3 different technologies. What I think it'd be useful is to just step through each one of these, doing its thing one time so you can see it in action. So we'll just start here. Again, all this code is in the repo, the same code repo we were using for Hamid's piece. And then there's an additional project I'm going to use here in just a minute. So if you don't have it yet, go grab it. There's more to it than just that first exercise that we did. So, okay, so we're just going to come in here, and again, we're just going to take a look at this briefly. So with your closure, well, I'll just start right there. So all we're going to do is just step through this. We'll go through this one quickly because everybody's familiar with how this works. Most everybody's probably familiar with how this works. Most everybody's probably familiar with how that works too. Okay, there we go. All right, so we're doing our query by food. Again, we're passing in just a single string to do this call. Here's where we're setting up that URL request, or that URL string, setting up the URL request using the string, and then setting up our data task here. Okay, so data comes back. We've got a list. If we've got the list, we need to now throw this call onto the main thread because this is tied to the view itself. Maybe. So we got to throw this onto the main view because this is updating the main view right here. So notice we have to add that extra code there. Then you'll notice we go through, we grab this category information, do the second call. When we do that call and get the result back, again, have to make sure that we're doing this, running this code here on the main thread because we are updating the UI as well as right here. Contrast that with this here, same idea, but with combine. I'm going to put a couple of different breakpoints in here just to make navigating a little bit cleaner. Yeah, that'll work. And we'll just kick it off a second time. All right, so you can see here in our combine, same idea. We do this query. In this case, we've got our result back. So now we're grabbing this string category, this category from the result. We're gonna then do the query on the food by category. Map that data, decode the data. Do we have an error? No. So we don't have to map the error. Send it back. All right. And then finally, we'll take a look here at our async awaits. This one, we'll step through this one a little bit slower just because, like I said, it is the one that we care most about right now. So we're just going to put a breakpoint on each of these. Kick this off one more time. I forgot to remove these breakpoints. So get our food by food name. Did we get it? Yep, we did. So you can see we await that response. Response comes back. Now we know we have what we need to move to the next one, right? We have this object. Does it exist? Yes. Can we pull the category from it? Yes, we can. So you can see we've got our category here. And then query our food by category. That runs. We get our result, sets it to the results by category. Because these are just set right inside of the view model themselves, we're not having to pass anything out of here. We take these breakpoints off and we'll just run it one last time. All right, so you can see same information coming from from the same endpoint with the same argument. So you get, at the end of the day, the data you get back is the same data you get back. How you get it, that's where the real power of async await is. Again, this is the kind of code I want to be reading, trying to debug, versus something like that. So, any questions? Anyone want me to show anything in particular on in the code? Otherwise, I will stop sharing for a minute.
Great demo. Thanks, Josh.
Perfect.
We can jump into the next segment, which is structured concurrency.
Okay. So here's where we get a little bit more nitty-gritty into a lot of the stuff we've sort of touched on in Hamid's talk, some of the stuff we sort of touched on in the previous comparison conversation. Structured concurrency, what is it? When you look at async await, it's clear it's a powerful tool. Again, the power of the tool comes from knowing how to use it as much as knowing when to use it and when not to use it. So, Swift concurrency is a task-based system that allows developers to take full advantage of the await piece of the async await, but while giving the user experience and the application the best overall outcome. So the power from async await comes from the fact that you're going to get that result back before you continue down the path. So the developer can trust, all right, I'm going to go send these workers off to go do what they're going to do. I'm going to get the thing back. It'll be here when I need it. I'm not going to move forward on this exercise until I have it. But at the same time, these other things can also be happening while I'm waiting for that task to finish. So structured concurrency is the how we take the different pieces of async await and tasks and task groups, bring them all together to give you that control to really optimize what it is you're trying to do. Again, we want to be making sure we're taking full advantage of the control, of the power of these devices that we have in our pocket, the power of the apps that we're given to consumers. The users are expecting a certain speed of things to happen on their device, and structured concurrency gives us the ability to prioritize and order things in a way to give them that snappy feel of their applications. So again, we can leverage the power of Swift structured concurrency to find the right balance between what to do, when to do it. So with structured concurrency, we got options. You've got task, you got async let, and you got task group. But before we get into the specifics and comparing the things, we need to be talking about some of the keywords that are going to come up or that have already come up. So a task, child task, cancellation, and priorities. So a task is a fundamental part of the concurrency framework. It creates a concurrent environment where asynchronous code can happen, where that is otherwise a non-concurrent function. A task will can return a value. A task can also throw an error. Tasks on the surface may look like a dispatch queue, but they are distinctly different. And so it's important that we don't confuse one with the other, and that we really understand the difference in how those things behave. A child task is a task that itself is generated and managed by a parent task. Any task that has been created in Swift can be canceled. Now, we'll get into a little bit what that means and in what cases, but a Swift task can be canceled. It doesn't require you to keep a strong reference. So in other words, with Combine, if you're used to it, with Combine, you have a publisher, you have a subscriber. As soon as you take the subscriber away from the publisher, that connection is broken. That code associated with that will no longer run. That's not true with a task. So even if and we'll get into some of the nitty gritty of this in a moment, in a few minutes as well. But tasks, generally speaking, either run to completion or are canceled. And if you don't cancel it, you can assume it's going to run to completion. Okay, and finally, priorities. We're not going to get really nitty gritty into this today. We can talk about it, but in the talk itself, we're not going to get too into the weeds about it. But if you're familiar with the QoS priorities, quality of service priorities, task priorities, they are going to look very familiar. So you've got high, background, low, medium, user initiated, and utility. It's important to remember the priorities are there to help the system make the best choice, but they're just suggestions. So the system's going to do what the system's going to do. There's ways for you to encourage that behavior, but it's not a guarantee. Okay. So let's talk about tasks. It's a little bit of a review from what Hamid talked about, but this is a basic task. Inside of the task itself, we've created a concurrent environment where asynchronous code can work. The compiler knows how to handle this. The compiler knows how to behave. This is a basic task. In a minute, we'll show a more advanced task, but the important thing is once you put this task code in place, there's a whole new set of rules and functionality that are going to happen. So once you've typed task into your editor, you've taken the first steps to writing concurrent code in Swift. All right. Cheekiness aside, here's an example of a real task with all of the moving pieces. So we just looked at this. Again, you can see we've got the task here on the outside. You've got the do catch where we're accounting for errors. In this particular case, we made the choice to let the errors propagate out should they happen instead of handling them individually, but regardless. All right, let's talk about a child task. Child tasks are very powerful, but they come with some caveats. So a child task is where structured concurrency really comes into its own, right? It's the ability to say, I'm doing a thing, now fork off and go do a thing over here and go do a thing over here. So a child task is a task that's been forked from a parent task, but it's bound to the parent in a couple of ways. So for example, a child task is going to take on whatever priority the parent task has. A child task can be canceled by the parent, or it will be canceled if the parent's canceled. Additionally, if a parent has multiple child tasks and one of them throws an error, the remaining running tasks will be canceled. And finally, a child task has to complete or be canceled in order for the parent task to complete. So if you've got some child task running off on its own, that parent task can't consider itself complete until the child task completes or is canceled. Child tasks can be created by different asynchronous methods. So we've got tasks, we've got async let, task groups. Again, there's an entire hierarchy to the parent and child relationship with tasks. A parent task can itself be a child task of another parent task. Parent task, again, can have multiple child tasks. A parent knows about all the child tasks, but the child tasks don't know about each other. So there's some localization understanding there you need to be aware of. Again, canceling a parent task will cancel all the child tasks, but canceling a single child task doesn't work up the other way and cancel the parent task. Now, let's talk about cancellations. Cancellations are one of the things there were some questions about earlier. So I'm going to try and answer them here, but feel free to raise your hand and ask them if we didn't quite catch it, okay? So cancellations, we're not talking about flights or Airbnbs, we're talking about code. If you're familiar with Combine, again, you've got that subscriber-publisher relationship. This is different from that. Once a task is started, it runs until it completes or is canceled. Something that's good to know is a task knows whether or not it's been canceled. So if you haven't been watching to see and adjusting, reacting to a task being canceled, you can just ask, right? You call task.check cancellation. If it's been canceled, it'll throw an error. If it hasn't been canceled, nothing happens. Cancellations happen in a number of different ways. As long as you set up things properly, you can explicitly cancel a task, but they also happen programmatically, right? So for example, if you throw an error, it's going to cancel that task from completing, as well as if that's a parent task, it's going to cancel the children task. If it's a child task and it throws an error, that's going to propagate out and cancel any of the remaining child tasks associated with that parent. And this one's a little tricky, but if you call task dot in Swift UI and you navigate away from the view, then navigating away from the view will cancel the task. However, if you call that task inside of on appear, you don't get that same behavior. That task will continue until it's completed or it's canceled for a different reason. Any questions on cancellation while we're here?
I had one question. So when do you use this an example like so you declare task as a variable in a class, and then you have multiple places you can call this task, and then you check for cancellation whether this has been canceled or not?
Yeah, that's a situation which you could do that. Yeah, because again, we'll show this in a minute with the async let, but yeah, if you just call task bracket, what we showed earlier, you don't have quite as much control over that. But if you store a reference to that task, yeah, you can cancel that task. Whenever you decide it's appropriate to cancel that task.
Okay.
Any other questions? I mean, we can come back to questions on cancellation. That's fine. I just thought I'd ask because I know we had some from before. Okay, perfect. Like I said, feel free to drop them in the chat. We keep them to the end, whatever. We'll get them. Okay, so let's talk about async let. So this is one of the ways in which you can control the flow of your application inside of Swift. So it's called async let. Does what it says on the tin. To use it, you type async let variable equals. Couple of things. It's powerful. Async let's powerful. What you're saying is, I'm confident that I can make this call right now, and it doesn't need anything. It's not waiting on anything to run, and it can run independently, and we'll handle the outputs in a minute. It gets executed as soon as it's hit. However, one consequence is you do lose some control. There's a loose control mechanism here, where you send that task off, and it's now running independent from whatever other concurrent stuff you have going on, and so it comes with a cost. It's probably worth it as long as you know you're using it in the right place. But it does have its cost. But anyway, it's important to understand, when do you use async let? So the most obvious situation is one-off situations, right? So I know I got two calls that are going to go off and do two separate things. I don't care what happens. I don't care who gets here. Neither one of them needs to know anything about the other one. So just go off, do your thing. Let me know when you're done. Another situation is if you have a finite number of calls, and we'll contrast this with task groups here in a minute, but if you have a finite number of calls that you're making, so every time this function runs, I need to make these 3 calls to 3 different endpoints. Yeah, as long as they can run independently, async let's the thing you want to use here. Lastly, if you're returning multiple data types, Again, I'll contrast this a little bit better when we talk about task groups, but if you're making 3 separate calls to 3 different endpoints, or even if you're making 3 different calls and the data type coming back is not consistent across those three calls, you're going to lean to async let, not task groups. Again, and just a basic example of this is, we're doing a weather app. We've got a region. We pass in the region to a function, and we want to get a temperature and a humidity for that region. When we reach that point, we already know what the region is. We pass the region in for temperature. We pass the region in for humidity. When that result comes back, great. All we care about is that we got both a temperature and a humidity. The temperature result doesn't impact the humidity. Humidity doesn't impact temperature. And frankly, we don't care which one makes it back first. So, and potentially in that case, we're getting different data types. We're probably getting different data types back. So it's an example of when you would use an async let. Task groups are a little different. So task groups are powerful because they're for when you don't know how many times you're going to have to do a thing. The task group and the items in the group get dynamically created as the code runs, so it's not known at compile time. Inside of a task group, there's support for parallel or serial processing, depending on what you're trying to do. One thing about the task group is you're going to assign n number of tasks and say, all right, everyone go off and do. And once all of them have come back, the task group says, all right, I'm good. Now I'm going to return something. So there's no partial return until all of those responses or all of those tasks, individual child tasks, complete. Again, compare this to async let. They're similar, but they really are specialized for different situations, and understanding when to use one versus when to use the other is an important thing. It's most important, it's most useful rather, when you're doing task groups that you're using the same data type. And I'll show you an example here in a minute that helps explain this a little bit better, but if all of your responses coming back from your endpoint are the same type, and you're going to group them together or calculate them together and return a single result, that's where task groups really soar. It's possible to do task groups and have different data types, but frankly, if you're looking to how to get around this when using task groups, you probably shouldn't be using task groups. So there are ways to get around it. I'm not saying you should never do it, but if you're looking at, okay, how do I get around this? You should probably just be using async let instead. This will make a little bit more sense here in just a second. Excuse me. So we've got 2 different examples of our task groups here. There's actually a little bit better explanation on the next slide, so I'm not going to go too deep into this. I just want to show the contrast between, in one case, we're passing around a bunch of strings, and the ultimate result is an array of strings. And then the other one, the task inside is processing and returning UI images, and then we're going to collect all those UI images into an array and return that entire array. But if, for example, inside of here, you're making one call that hits, returns a string, and one call that hits and returns a UI image, this gets really messy really quick. It's difficult to piece it all back together and return it clean. Okay, so excuse me, here's a better example. excuse me, of a task group, a real task group in motion here. You can see, we'll just kind of start at the top. So you've got your await, right? Telling us, hey, this is an async call. We're waiting on this response to come back. Everything in here is all going to finish, and then a final thing's going to come back out. So with task group is the syntax there. The of is the initial thing that we're handling. So in this case, UI image, and the returning is what's going to come out of it. Now, there's different function definitions and different ways to initialize a task group. I just picked this one because I think it fits most of the cases most of the time. Once you kind of understand this one, it's easier to jump to the other kinds as well. Okay, but you'll see inside of here, we've got and I spelled Salt Lake wrong. My apologies. I didn't notice that till just now. We've got a first endpoint where we're passing in a keyword. The result of that keyword is a series of URLs associated with photos. We group all of those URLs into a group. Then inside of the task group, we pass that URL into the download function. Once that URL comes back, we get the URL, we download the image, we convert that to a UI image. That result now becomes part of our task group. So your task group.add task, you should have left line numbers on there. There in the middle is where we take that UI image that's coming out of our download function and puts it back into our task group. And then secondarily, here we've got a for loop that's taking each of those UI images and grouping them together into an array of UI images. So then that UI image gets returned. So again, you can see here up at the top, you've got that returning is an array of UI images. The object that's getting passed around inside of the task group is a UI image individually. Again, hopefully this illustrates a little bit why the return types being the same is really important, really useful for data tasks, task groups. Forgive me again. Why it's important for task groups, but doesn't work so well if those data types are different. So let's talk about what we've talked about. Excuse me. Structured concurrency. What is it? It's taking control of running those asynchronous tasks in Swift, fully leveraging our devices, the cores, everything that's in place. Why do you use it? Better user experience, better control of the flow of the application, easier to use, easier to understand. The keywords, right? Tasks, child tasks, task groups, task cancellation, priorities. What are a couple different ways that we can use it? Async let and task groups. When you want to use async let, immediate execution and a finite number of calls at compile time. And again, if you're dealing with different return types. And then task groups, you have a dynamic number of calls that need to be made to the same function with the same return type. There are so many resources for getting into this. So, if you just Google structured concurrency in Swift, you're going to come across thousands. But I've pulled some of them, again, that I already had bookmarked, that I've referenced in the past. I went back to for parts of this. Make sure you refer to Hamid's talk earlier about async await. Tasks in Swift explained. What's the difference between await and async let? Task groups in Swift and exploring structured concurrency in Swift. There's a breakdown of that WWDC talk. So
By the way, great presentation, Josh. Thank you for talking about both topics.
Yeah, if you don't mind sharing your screen. So the project it's in that same folder. But it's a different project.
Okay.
I didn't want to mess up all that good work Hamid did.
So is this the one?
Yep, that's the one.
Okay.
All right, and I neglected, I don't know how I messed this up. We'll get this put into the README, but it's not in the README right this minute, but it is in the Zoom chat.
Okay.
For what we're doing.
You said async let or task groups, which one?
Dealer's choice. Which one do you want? You want to do async let or do you want to do task group first?
I think we can start with async let.
Perfect. Okay. So here's what we've got. We've got a series of async functions, and we want to get stretch those fingers, get them used to writing the autocomplete for async and async let. So what we want to do is we want to use these stat generations, generate age, generate height, generate eye count, generate hair type, get those values generated, and then use the hero initializer to create your character. So you've got the async let view and the async let view model. Those are the two we're going to be playing in for this first little bit. We've already gone ahead and got you started right there at line 18. That's where we're going to be doing the bulk of the work. We've already got you a task set up, so we know we're already in structured concurrency mode. What do you think? What should we do first?
I think you need to call all these methods.
Perfect. Perfect.
So, okay, so it's async let. Is there any syntax for this? I think this is
so this will be good. Write it like you didn't know async let was a thing, and then we'll convert it.
Let age equals.
Perfect.
I count.
Oh.
Got to keep people on their toes.
Then add async.
All right. Perfect. Okay, so you'll notice compiler's saying, hey, wait a minute. It's async, you didn't mark it with a wait. Okay, so yep. Okay, go ahead. So go ahead and do that for all of them.
Oh.
But this is an exercise. It's just generating a random number.
Yeah. Don't show behind the curtain, Joe. I'm just kidding. Okay, so this is your normal await situation, right? What we're gonna say is, don't use await, use async let. And like I mentioned earlier, it does what it says on the tin. So get rid of await and put async at the beginning, so that it says async let age equals.
Async let, okay.
Okay, so now we've got a hero object that you can just create. It's just so let character equal hero, or sorry, not let, just self.character equals.
Do I send? Do I use it directly?
Yep,
here?
we're just going to take those values and pop them in there.
Okay.
Okay. Let's go ahead and yep. Oh, so yeah, we do need to set the set that to await. Yep. Let's go ahead and run the code, and then let's just talk about this for a little bit. Oh, we may have to. I don't remember what I set the content view. Forgive me. Do you want to just jump to the content view file real quick? Yep. Okay. Perfect. That's the one we started with. Okay. Let's go ahead and click on generator character stat. Now, this looks familiar.
Main actor.
There we go. Main actor. Good. And yeah, let's just kick it off again. All right. And then you can click it and it'll continue to just regenerate different stats for you.
So async let is different than let age equals async.
Correct. Let age equal await. Yes.
Okay.
Yeah. So what you're doing here is you're telling the compiler, I know that these calls I'm about to make run independent from each other, right? So on line 24, we're saying, wait, you got to wait until we have these values. But for 20 through 23, these values don't matter to each other. They can go get independent, get set, and when they're all set, we pass them all into that initializer for hero. Right? Versus contrast that with if it was, let age equal await generate age, it doesn't know. You haven't explicitly said, do I need to wait for this to finish before I call the next one? I need to let that one finish before I call the next one. So by marking that as async let, you're explicitly saying this can go off on its own, run independent. When the answer comes back, we'll use it in the initializer, but we don't need anything before that. We don't need anything. We'll know when to use it afterwards.
This is kind of like the dispatch group equivalent, right? Of what we used to do things before, kind of.
I would say this is kind of similar to like the old invocation. And yeah, you can also do it where if you have a group and you're trying to make sure that everything is received first, then yeah.
To me, it's more like NS operations or operation queue.
Yeah. I think that's fair.
And it's a let constant. It only gets one value. It can't change.
Correct.
Yep.
Any questions? I tried to keep this real focused on the concepts we're talking about. So I know it's not nearly as fancy as the stuff Hamid was doing, but I just want to draw your attention to a couple of things. So yes, we are returning a couple of ints. So that could be done in a task group, but remember, we're doing separate calls to separate endpoints, really. And additionally, one of those value types coming back, the hair type, is an enum of hair type, right? It's not an int. So right there, first, you look at the first thing, you say, are they all ints? Well, nope, they're not. All right, well, we probably ought to be doing async let. Also, are they hitting the same endpoint? No, they're not. All right, well, now we know it's async let. So I'm trying to give a little bit of a key in mentally on how to think about breaking up your problem and whether or not it should be async let or whether it should be task group.
How do we handle situations like a zip and combine? Like, for example, let's say the character, self.character has to wait for eye count and hair type to be completed first.
So let me say what I think you said.
I guess a zip will be similar to this. Yeah, I think so. Yeah.
Well, so the initializer is going to wait for those values to come back, right?
Yeah.
So that's where we're halting, but the actual getting of those values happens independently, right? However, when you start talking about zip, let's say you were hitting 3 different endpoints to get average temperatures from 3 different sources, right? And you wanted to pull all those temperatures together, zip them all to get a big average temperature.
Mm-hmm.
That's the kind of situation where you really have to ask yourself, you know, I'm already doing it in combine. It's maybe worth keeping it in combine because of the specific nature of what I'm doing.
Right.
Right. So, you know, async await isn't there for everything all the time. You still want to, you know, reflect on whether or not you want to make the change.
Okay.
Any other questions on this, or do you want to jump to the second exercise around task groups? All right, perfect. Spin the wheel, spin the wheel, spin the wheel. Andrew, do you have the code pulled up?
Sorry, yeah, 1 second.
Perfect. Thank you. Is this, and are you sharing your screen, Andrew?
No, I'm just trying to.
Okay, okay. I was gonna, yeah, okay, perfect.
Yeah, just give me a second.
Oh, you're fine. Yeah, you're fine. I'm curious, thumbs up if you run in dark mode, thumbs down if you run in light mode in Xcode. What do we got?
Dark mode all the way.
Yeah.
Trick question, there is no thumbs down.
I am fully automatic. I love the switching from light mode to
There you
dark.
go. I don't use dark mode in Xcode, so
I switched my stuff to light mode because it looks much better on slides, but it was painful the entire time. Okay, so for the second exercise, oh, forgive me, Andrew, we're going to go into, it's in the same folder, but it's a different project.
Oh, okay.
It's called structured concurrency.
This one?
Yeah. Yep, that's the one. And yeah, just the Xcode project there. So for this exercise, we're going to be doing task groups. So everything you need in the task group view, excuse me, group. You've got the task group view and the task group view model. Now, if you search for task groups in Swift, you're going to get a whole bunch of examples of how to do this with images. And I wanted to give you something a little bit different. So let me just take a second and explain what's going on here. Because when it comes to images, you can Google it and you'll find another example that does what you're looking for. Excuse me. So what we've got is we've got an array of 50 words. And we're going to do 2 things. So inside the task group, we're going to say, hey, go get me 5 random words from that async method. Then group those words into an array of words. And then take that, assign it to our generated strings, which makes the view look nice and pretty. So if you want to start just by jumping to the content view, Andrew, and switching that from the async let to the, sorry, forgive me, over on the left-hand side.
Oh, content. Yep.
Just change that from the async let view to the task groups view. line 13, line 14.
Okay, so yep.
Perfect. Okay. Now, quick note for anybody, especially if you're popping in or out, or if I'm moving a little too fast, all of the code we just wrote, very similar code, is on a separate branch in the repo for this project, as well as what we're about to do here. Okay, so Andrew, if you don't mind, just jump over to the task groups view model. That's where the real magic's going to happen with this one, right there on line 22. That's where we're gonna do the work.
So
now, yep, perfect. So couple of reminders about how task groups work, right? We've got the with task group code. So if you start typing with the something, say generated strings equals await with task group, the autocomplete is going to really help you out here. Perfect. So go ahead.
And that I was looking for the thing that passes the task group through the closure, and that's it.
Yep. So you've got your of, which is the thing we're going to be kind of passing around, and then we're actually going to change that slightly because we're going to put a returning value as well. But for the of, we're going to be working with strings. So you can just do a string.self.
is that in an array or just?
No, just a single string. The value we're passing around inside is a single string.
Okay.
And then you can get rid of this and replace that with returning, or add a returning there.
Where, so like?
Yeah, right there, returning. And that's going to be an array of strings.
That's self.
Okay.
Yep, dot self. Oh, dot self on the outside. Perfect. Okay, so then inside of here, right? We're gonna have a task group, right? Is a body of information that we're holding. So you can do a task group in. And then I'm going to take a half a step back, let anyone else who wants to input can make suggestions.
Somewhere task group.add.
Yes,
Yeah, somewhere we need a task group.add, but yeah, I don't know what value you want to pass.
So first thing, we want to do something 5 times. Okay, so the task group itself is going to get those random strings, right? But we want to tell the code to do this 5 times. So simple for loop with this on the inside. Yeah. Perfect. Yeah, and this is, there's a lot that can go here, right? There's a lot of configuration you can do on that task. We're just going to keep it plain and simple. So you can just do add task, open bracket, close bracket. We'll put the work in there.
I believe we want a random string here, Andrew.
I guess put await. Not sure.
Yeah, you're gonna want that await on the inside there.
Yeah, inside before the
Next
function.
to the random string, right? Now, similar problem is what we ran into earlier, right? At the end of this, it's expecting us to return an array of strings. So that's what this is. This is what it's currently barking at. Is we're doing this task group, but at the end of it, we're not returning the array of strings. So, okay, this is good so far. Now, there's a couple different ways that you can do this, and it really depends on what other stuff you want to do. I'll describe one way, but basically we want to create a temporary array of strings that we can add those strings to, and then we're going to return that temporary array of strings. So outside of that for loop, because what we're saying is, all right, I need you to do this 4 times. Go into this for loop, give me 5 random strings, and assign those strings to this task group, right? Then once that's completed, let's create a temporary array of strings and then do a second for loop and loop through the task group itself.
Sorry, am I supposed to be coding here?
No, you're fine. So yeah, on line 26, let's create an empty, outside of the for loop.
Okay, yep.
Let's create an empty array of strings. Yeah, perfect. All right, and then what we want to do is loop through that task group, get the value from that task group, and append it to that array of strings. So again, we'll just do a for loop, for word in task group.
You could use for each, right? That's
yeah, you could. Yeah, you could. It just depends on how you want to define it, right?
It's not giving you that option.
And then so inside of here for each, for word and task group. So inside of here, each one of those strings, you're just going to append to that strings array.
Word.
And then
return strings.
Yep, return strings. And I'm not sure with that add task operation. I don't think we want to give it that operation. I think we just want to do add task, open parens, excuse me. So no parens, sorry, open bracket, close bracket. After the add task.
Am I doing add task or just add?
Add task. Because what inside of there, right, is you're saying the task is the getting of the random strings in the same way that the task would be, going out and downloading an image from a URL. Yeah, and then inside of there, do your await.
Closure.
So when you do an add, does it do an auto execute right away, or is that 2 separate steps?
It's now a child task that it can just decide when to execute it, right? So you don't have to tell it to execute. It now knows it's part of the group to be executed. But if it's been put to sleep, or if it's been, it's a lower priority, it will execute whenever the system tells it to execute.
Okay.
Sorry, what's this? Oh. Hold on. Why? We don't need to word in task group because we can't do it this way.
It can be a counter. Yeah, task group.
Because I didn't, we didn't.
Try for each, but I think that requires ID.
No, that's not gonna work. That's why it wasn't coming. Shouldn't this be?
Yeah, because I'm sorry, folks.
We have to wait.
Strings. Mm-hmm.
Is there a task group dot children or something? Tasks. No.
Is it dot count something?
Enumerated.
Okay.
For a wait word.
Yeah, you need to add an await to the in between for and word. What? And now that up there. Okay. Air string, pen, word. What? Add task. Got that. Await. Good. Random string. What?
No, you better not. What I'm thinking is take out a temporary variable on line 20 after 26 on 27. Let name equals await, self dot random string, and just use that name captured in the closure.
I think your Xcode might be a little confused. Can you do a clean and build? Because there's nothing.
It's compiling.
I think it is gone. Yeah. I'll fail.
It really, I'm sorry.
What's that?
Everything looks right, so I don't know. Trying to look for places where we could have maybe done something a little.
It's not showing up there. Cannot convert.
Yeah. So in your strings here, sorry, on line 32, make that, instead of an empty array, make it a new array of strings.
Are you building, Andrew?
What? Why doesn't it like you, Andrew?
Maybe which version of Xcode are you using?
14.1. Would you cover of type string?
Is it possible that it's weak self?
What about our parameters than
Oh.
returning?
No, those are right. What on earth? Turn types. Turn strings.
Can you try getting rid of the weak self and try it?
What is the type of this generated strings in line 42?
It succeeded.
Oh, that's what it was. It was on that return on line 24. Good call, Nader.
Did it work?
I believe it will work this time. Yep. Do you have your simulator up, Andrew?
It's loading.
It's thinking about it.
Right.
It's always one thing that makes
You just need the right magic incantation.
Yeah, here, hold on. If I 1 foot, got my tummy.
So the with task root of string, is that related to our first for loop that the task has a string in it?
Yes.
The returning is the results of it.
Yes. Oh, and in the view model, we just need to set that to the view. My apologies. But yeah, Joe, that's because that first result inside of your task group is what you're working with, right? Which in this case is strings, but it could be a UI image. The returning is, we're explicitly saying we're going to give you at the end of this an array of strings. We could just as easily set it directly to the view model and remove that returning part. But yeah, that's how you differentiate, or that's how you kind of understand what goes in the of versus the returning piece.
And the result of our method is an array of strings.
Yeah, so Andrew, if you want to just go, instead of setting that to your let generated, well, yeah, there you go. You can set, you can either set it there or inside the function itself. So yeah, right now we're setting it to a local generated strings, but if you wanted to, yeah.
Wait, so what's the issue? It's
so right there on line 23, right? We're setting it there.
Oh,
when
I see.
we're calling it, we're not setting it, so we can either set it inside of the function itself, or we can set it externally when we call it. Yeah.
The published one.
Yeah.
Nice.
Like I said, it's not as fancy, it's not as whatever, but I like the idea of focusing on just the piece we're working on, so you can try and keep everything straight. So again, all of this is in the final branch of the repo. You can go and look at it. It's got all this code in there. From here, start playing with priorities and parallel calls versus synchronous calls in serial calls in inside of the task groups, et cetera, et cetera. But that's what I've got. Any questions on what we did or why?
Hey Josh, good job, man.
Thank you. Appreciate it.
Yeah, great job, Josh. So with that said, let me just move into kind of like the last portion of things. And you can definitely ask questions because it is more of a discussion. So let me share my screen. Can you see my screen?
Yes.
Okay, great. So just wanted to kind of get a feel and just start a discussion here and try to figure out, what do you think of async await based on, what you've seen from the sessions that we did, as well as the code and all that. What did you like about async await? And so let's start with that question. What did you like most about async await?
Precise, simple.
Yeah, definitely. And Josh was able to show that, just kind of going in between the closure, which is like 20 lines of code versus like 4 lines of code. Yeah. Any other things that you like? Or anything that you did not like about it?
I like that the compiler actually can catch some of the issues with the code. For example, like with the closures, you can have like dead paths if you never call the completion, for example, in your error handling or some odd case scenario. With async await, because there's always a return value, compiler can actually catch all the paths of your code, and it basically forces you to not to call the completion, but to return a result. You see what I'm saying?
Yeah, exactly. And that's where, the previous with closures, it's prone to errors, right? This one, it really makes sure that you do have that. So yeah, great point. Any other things that you liked or didn't like about it? We'll move on to the next question. Okay, great. So, this is kind of related in a way as well. How do you think async await compares towards the other concurrency techniques? Do you think that this is something that that's easier? Are you going to be using it?
Sorry to interrupt, man. Like in my workflow, I use async a lot, but it's just like the combine and like debouncing search stuff. It's a lot easier.
Yeah.
I'm not sure if you guys the async synchronous thing. It's a bit more like mind blowing.
Yeah. That is a current limitation of async await. Yeah.
And also when you need to do like any kind of reactive task, reactive work, then combine definitely wins there. Yeah.
And I just want to add, you guys seem like a great team. Kudos to you guys.
Thanks, appreciate that, Martin. It was a team effort. There's a lot of people that helped out with a lot of the presentation and a lot of the code that actually did not present. So thank you for mentioning that, Martin. And I do want to thank them. I know Othmar, Michael, Rihanna, Andrew, and a few others, and Nikolai definitely put in effort here too as well. So thank you. Okay, so then if you are not using it, is that something that you see yourself leveraging and integrating into kind of like moving forward with anything that you're building?
Yeah, I personally definitely prefer async await, but the like we mentioned previously, like limitations. Although our like support model is iOS 15 plus, so no issues there. The problem is that we still have a good chunk of Objective-C code in flagship, for instance, right? So you can't really use async await APIs wherever that's the case. So that's definitely a limitation. Another thing is that like async await, and it's a pro and a con at the same time. Like async await, it enforces a certain type of a pattern, right? Like because we just compared it to combine, doesn't fit too well into reactive pattern. However, I kind of like when API sort of enforces a pattern as well, because I normally would prefer consistency over like a preferred way, if you know what I'm saying. But yeah, there are still some limitations, unfortunately. But it's, in my opinion, definitely a better way of doing asynchronous programming.
And you know what? Hopefully, once we migrate a lot of the code to Swift, then a big portion of that limitation is going to go away.
Yeah, and any other language really had this for a long time, right? Like on Android, there are coroutines that are very similar to it. It's just, yeah, it totally makes sense for this thing to exist, for asynchronous code to be actually written in a synchronous manner.
Exactly. And Apple's pretty good at keeping up with technology. Once they come up with something, even if it's not as mature, they're able to mature it in a very short period of time. And they keep updating and updating so that it, even if it's not as mature now, it will be able to cover all the edge cases, I think, in the near future. That's one thing they did with like Swift UI, for example. Even though that there are still a little bit of limitation, but they motivate you to start using the latest technology, and they start pushing towards that and supporting those technologies much more than the legacy technology, or not necessarily legacy, but the previous technologies.
Yeah, and if the structure of the project, if project is complex and it's modularized based on frameworks, then I think combination can also be used. For example, if you want to stream something, live streaming or something, maybe you can use combine for using publishers and all that kind of stuff to get that reactive approach, and use a different module, a different framework with async await. And by the time that things get mature, it's going to be easier for you to take that out and put the async await, or vice versa.
Yeah, and I think Josh did a good job there, like with the slide, with the right tool for the job kind of thing, right? Like just don't try to just don't just blindly do it. Let's put it this way, right? Like
yeah.
If I could make one comment on that one, I think I've used RX Swift for years. I've used Combine for a while since it came back. And there's cases where it really fits the pattern, especially like if you want to subscribe to a stream of events, like, rotations or something like that, right? Those are the kind of things that works well for, as opposed to async await. But I can't think of anything like networking where I would really prefer Combine over async await. I think async await beats it hands down, especially like, when you start trying to do things where, oh, I need to do consecutive calls, and now I need to do a flat map inside of a flat map inside of, there's that whole mindset that you have to do that just, it takes a while for some people to get.
Yeah. Sorry, I didn't mean like in terms of like straight up make a network request. I meant like specifically cases where you have like multiple observers that are interested in like a stream of things, and with async await, you can do it, right? But it's just combine gives you the like out of box a lot of those hooks that async await doesn't.
Combine has the marbles.
I was going to say the classic example that you see a lot in Swift or Combine, you know, where you're saying, oh, I'm typing something to a box and now I want to wait for a little bit and then automatically do a lookup on an API call, but I want to cancel that call if they keep typing. And, you know, that's hard to do in the sync await. But Combine makes that easy. It's just a little stream and it automatically cancels and it's all great. So there's good choices for it, but for the most part, I've migrated.
Michael's already done with everything else.
Well, it sucks because I spent a long time learning RX Swift, and I'm a contributor to the project. I mean, I've been inside of it, but
yeah,
its time is sort of by.
Yeah.
I have a question about the entire presentation.
Yeah, go ahead.
Structured concurrency. Hamid told us about how good it is and stable it is. What about unstructured concurrency? I haven't. I looked at the programmer's guide a little while back and understand a little bit about it. Is everything that we've seen here all structured concurrency? 1 and 2 is all of async await structured, or can you have unstructured concurrency with async await?
So an example, so if you've got various tasks, right, that are codependent on each other happening, and then you fire off an async let, right? You're taking control back to say, these are things that need to happen asynchronously together. This is something I want it to happen asynchronously separately. In my mind, that's the structure part of it, is you're controlling what happens when. But I mean, you and I, we can talk offline and get more into the weeds if you want, but I guess maybe I don't quite understand what you mean when you say unstructured.
Well, what my knowledge is so far, what I read, like with structured concurrency, you get into the least of your concurrency issues. For example, deadlocks, race conditions. If async await is already offering structured concurrency by default, then obviously my assumption is going to be that the task performed by async await is a high performing task. It will fall into the less concurrency issues, including deadlocks, race conditions, or any other concurrency related bugs. So that's why I guess a structured concurrency is better option to consider. I'm not clearly sure in what situation you want to use unstructured concurrency.
I just think unstructured, you have to take control of what you add to a group and whatnot in task. Yeah. Okay, thank you.
Hey guys, this is a very, very nice workshop and very informative. And I did on and off joining this presentation. I'm wondering if you guys show us like converting completion handler into async await, like using with check continuation, stuff like that.
I'm not sure. I thought. Can you repeat the question?
So from my search in Google, we can change the regular completion handler, and then we can switch it to async await. And to do that, we have to use a wait check continuation. Did you show us to do that today or no?
As I kind of understand, I mean, if you're using with continuation and with unchecked continuation and all those fun things, those are kind of ways to bolt on async await to things that weren't really designed to be async await to start with. I mean, it's like you can use with unchecked continuation for something that had a completion handler and then map that to an async await kind of result. Is that answering anything, or am I just
sure? So yeah, what I'm saying is that did you demo that today using with check continuation?
No, we did not.
We did not, no.
Okay, gotcha.
And that's kind of like my last question here is there anything else that you would like to see? So one of the things that we do is we do lightning talks every Thursday at 5:15. Each week it's a different practice that does it. iOS, Android, web, cloud. So if there's anything else that you are actually interested in that we didn't cover, like this is quite a big topic. We can actually spend a lot of time talking on this and it still won't be enough. So if there's anything specific that anyone is interested in, we can definitely add that to one of our lightning talks, and we can, it's broadcasted on LinkedIn. So it's definitely something we can do. So that's my final question here is there anything else that you would like to know that we can help with?
Yeah, I think that's one suggestion. I like to see how to convert the regular completion handler and switch it into async await.
Yep, we can definitely add that. We can look into it for sure. Any other topics that you would like to see? I mean, right now, even though this is async await, but if there's anything else that you would like to see, we're also able to do that. Okay. You can always reach out to us, and then we can always cover those topics. Are there any other questions that anyone has? Parag, do you want to take a moment to close this? Just before you do that, I just want to say I love this. This was really an engaging experience, right? I really loved the passion that a lot of people put in this. From sharing your screen, Usha, I appreciate it. Rohit as well, Andrew, and hopefully I didn't miss anybody. I really appreciate you sharing your screen and taking that that risk of being in front of everybody and learning this. But you definitely helped a lot of people learn and ask a lot of questions. I really think it's really valuable to not just understand something, but if you don't implement it, you kind of lost half of that knowledge, if not more. So I really appreciate all the presenters and all the hard work that was put into this. And I do appreciate the audience. And if there's anything that you would like to know more about, please reach out to us. And I'll definitely, upload a lot of all the PowerPoint presentations that we had. And yeah, thank you all. Frog.
Thanks, Nader. That was really, really good. I want to thank all of you for participating. And like Nader said, so many great questions, so many awesome answers. And yeah, special thanks to Nader, Josh, Hamid, Michael, Otmar, Rihanna, Andrew, Nikolai for putting together this workshop and doing such an excellent job hosting it. Right, it was super informative, and most of all, I really enjoyed watching you guys collaborate and help each other out. I hope you all enjoyed this experience too, and we would love to gather some feedback. Ted is going to launch a feedback form. If you could quickly give us some feedback on how we did, how would you like us to improve upon. You can also add in your email address if you want to get invites for future events. That would be awesome. Also, I want to speak a little bit about this overall series of workshop that we're running. So today's iOS workshop, it's a part of InRhythm Quarterly Summit, where we are hosting a series of 6 hands-on interactive coding workshops on latest technology trends. And our next workshop in this series will be hosted tomorrow at 1 p.m. Eastern Time. That's gonna be by our DevOps practice, where we will have a session on some of the modern DevOps tools, and we will be learning and using Pulumi, which is an open source infrastructure as code tool for creating, deploying, and managing cloud infrastructure. You'll also learn about how to find cloud cost estimates for Terraform using InfraCost. All of you know, in current economic conditions, everyone is trying to cut costs, save costs. So learning infra cost is the need of the hour. You'll also learn about how to build developer portals using Backstage, which really simplifies it. It could be a handy skill to have. So super excited about this workshop tomorrow. Let us know if you want to join it or if you want to share it with your colleagues. And yeah, make sure you have it on your calendar for tomorrow from 1 to 4:30 p.m. EST. Thank you all once again for joining. I would love if you could drop in that feedback. And yeah, all of you have a wonderful evening, and I'll see you guys soon in one of the next workshops.